Good afternoon again, fellow scholars. It is Chris Crowe once again back with you for another lesson. This time we are looking at Module 1, Chapter 8, Algebraic Reasoning, Graphing, and Connections to Geometry. Now, without further ado, let us get into the video. So, our first question is actually cut up into several different parts. The objective is to draw or otherwise form a graph for each of the scenarios represented and explain why the graph works. So here we have our first graph. You can see it's a slight zigzag going down, then up immediately, and then back down over a gradual amount of time. Now for this scenario, the x-axis, or the horizontal axis in this case, will represent the distance in miles that a vehicle is traveling before, after, and during gas up. And the vertical axis will represent the gallons of gas. And the reason this graph works for this particular scenario is because, as you can see, starting off, the car is going a certain amount of distance and then it stops to fill up its gas. And since it's not moving at all during this point, the distance completely stops. There is no progression forward. However, the filling up of the car causes the gallons of gas to increase, whereas it was somewhat low and getting lower with the distance. And once the car has been refilled, the line goes back down gradually. As the distance increases, the gallons of the car will decrease. Now, moving on. No, actually no. You can see the star representing the vehicle. The second scenario has to do with an elevator. Now, the horizontal will represent the elevator floors, and the vertical will represent the elevator height. So the elevator is going up and is stopping at every floor as it goes up to the top floor. And the reason this graph is accurate to the scenario is, as you can see here, that little box will represent the elevator. It continuously goes up, and the only reason it stops and stagnates is because it's stopping at a floor to let people off or allow people on. It never decreases, it never stops moving upward. It will stop, but it does not stop for a very long amount of time. It continuously goes upward like a step stair. Now, our third scenario has a bit of a squiggle graph here, and the reason it's accurate for the scenario is because the horizontal line will represent the distance from the table that a ball bounces when dropped, and the vertical line will represent the height of the ball as it's dropped versus when it finally stops bouncing. So here we have a little yellow ball, and we're going to watch it play over the entire graph. Now, as you can see, the height of the ball gradually decreases as the distance from the table increases. The reason being is because the first bounce that a ball makes after it's dropped is going to be the highest, and then each subsequent bounce is going to lose momentum, and eventually the ball will stop moving altogether after its final bounce. However, it will have traveled a significant distance from the table. Now, our final scenario is a gradual curve. And the reason it is accurate for the scenario is because we are looking at the shadow length of a flagpole as the day progresses. So the horizontal is going to represent the shadow length. The vertical line is going to represent the time of day. As you can see by the sun we have here, as the time of day increases, the shadow length of the flagpole will also increase. At a certain point in the day, say noon, there may not be much of a shadow, but by the time it's, let's say, 4:30 to 5 p.m., the shadow is going to be incredibly large because the sun has moved to an angle where the shadow can increase, maybe even overcome the actual height of the flagpole itself. Those were more critical thinking skills and just general common sense knowledge, especially given the variety of different options we could choose from as far as graphs were concerned. Now, our second question is going to deal with functions. Now, functions, Can be a bit confusing at times and maybe even a bit intimidating, but at no point should you ever allow yourself to be confused or scared, because they are not that difficult when broken down. So here we see the equation f of x equals f of g of x. Again, that might seem intimidating, but once I explain the whole situation here, you should hopefully get it with a bit more clarity. The antithesis of that equation is going to be g of x equals g of f of x. A almost complete reversal of the letters and their placement in the equation. So here we see that f of x is going to represent 3x. G of x is going to represent x plus 8. And here we have our total most understanding of this equation and how it's going to function. So we have the full equation g of f of x, with x representing the numbers 0, 1, 2, and 3. We're going to give you an example, g of 4. So g represents 4. So in the full equation g of f of 4, we have to figure out what number is represented by f. And so we see here, in the first instance, we're going to use, we are going to use g of f of 4 equals g of 3 times 4. So in this case, x would be representing the number 3. And so we'll do 3 times 4, so it becomes g of 12. And then we simply remember g of x is x plus 8, so 12 plus 8 equals 20. So now we will move on to our actual first equation. We have g of f of 0. So we know that x is 0. So we're going to do g of 3 times 0, because f of x is 3 times x. So 3 times 0 is 0, so g of 0 equals 0 plus 8, which obviously equals 8. The second one is g of f of 1. So x is 1. So g of 3 times x, 1, is going to be g of 3. And then we simply take 3 and add it to 8 to give us 11. And the next two will follow the similar patterns. G of f of 2, 2 will replace x and all of the rest of the equation to come, leading to 6 plus 8 equaling 14. And finally, g of f of 3. So obviously, 3 is going to replace x, so 3 times 3 is g of 9, and then 9 plus 8 is 17. Now, moving on to question number 3. The goal of this question is to show and explain slopes of the line segments by the given pairs of points, and to distinguish whether the segment is vertical, horizontal, slopes upwards to the right, or slopes downwards to the left, to the right. So here we have our graph, and we have our points, P and Q. We have 3, 1 for point P. I should have labeled them, and I'll make sure to do that next time, but point P is at the bottom at 3, 1. Point Q is at the very top at position 5, 5. So we're going to throw our line through those points, and then we're going to bring down this line, this secondary vertical line, through point P, and then we're going to form a triangle in the middle of that, which, if you notice, has one right angle, focusing in on point Q. And you can see, if you count from one point to the line in which point Q is on, we have 4, going upwards 4, and running 2, rise over run. So, following m equals y2 minus y1 over x2 minus x1, the slope formula, we have m equals y over x, 4 over 2. And the reason we have 4 over 2 is because in a normal situation, you'll write out the actual numbers as part of the slope formula. So in point P, you have 3, 1. That's going to be x1 and y1. Point Q is going to be 5, 5, so x2, y2. And you'll arrange those as they are necessary according to the formula. I'm simply skipping ahead to show you the results of the correctly done formula. So we have 4, 2, which equals 2. The next function will follow, the next line segment will follow a similar path. Now you can see here we have points P and Q again. We have 5, 8. We have 5, negative 8. Which, according to the graph, is a completely vertical line. Now, once again, we're going to use the slope formula. There's no triangle to form from this because of the fact that it is a singular vertical line. There's nothing to create there. So we have our y over our x, which means we have our negative 16 over our 0. Once again, you're going to place the points. You're going to place the numbers of the points throughout the formula and figure out negative 16 and 0. And since it is over 0, we have 0, because anything divided by 0 is 0, which explains the vertical line. Our third example, we have points P and Q for the last time. We have negative 1, negative 4, point P at the very top, and we have point Q, negative 4, negative 13. So once again, we're going to throw our line through. Now notice, the arrow is going down this time on the line. That's because all of the points are negative. It's a negative line. So you have to make sure that you're putting the lines in the right quadrants by following the correct points. In this case, this is the bottom left quadrant of the entire graph. So we have our triangle. And if you notice, we do have the right angle, or close to a right angle. We will once again implement our slope formula, giving us negative 9 over negative 3, which will then give us 3. Now, moving on to question 4, the objective is to show and explain the following functions, describe their similarities and their differences. So here we have our number graph, or line graph, sorry. And here we have y equals x squared. Bringing this down, we have y equals negative 2. And the reason that is squared is because if you see our x's here, these are numbers that you simply create for the purpose of the graph. They could be any numbers, but negative 2 to positive 2 is a good starting point. It's a good solid set of numbers that will often give you the answers that you're looking for. So it's largely as simple as plugging in these different numbers into the equation y equals x squared. And from there, you will simply plot the points given to you from this formula, and you will do your slope. Or you will do your function. And keep in mind that you also have to describe their similarities and differences. Now, this is the first one. There's nothing to describe or compare it to, so we're going to move on. And the next one will follow a similar pattern. Once again, y equals x squared, but this time it's plus 7. Now, don't be scared just because it's bigger. So, like I said before, we're going to implement negative 2, negative 1, 0, 1, and 2. Again, solid set of numbers to use for these types of function problems. So we will implement each of the x numbers to find the y numbers. Once that's been accomplished, we're simply going to plot the points, and we will have our second function. Oop. PowerPoint, so tricky. Now, we have our final formula. Rather, equation. This time it is y equals x squared minus 7. So familiar, but not the same. Again, don't allow yourself to be scared, because we're going to follow the exact same formula, of implementing the x numbers into the equation, which will give us our y numbers, which we will then use to plot the new and final points of our final function. And if you'll notice, each function is a vertical change from the other. One is further up on the graph than the original, and then the final one is further down than both of the previous. Those are vertical changes. Now you should do well to remember those. Now, number 5, we have to show and explain the equations of a line that's perpendicular to the given line. So here we have the equation y equals negative 3/4 x plus 5. And the point r, 6, negative 1. So here we have our graph, and you can see that 6, negative 1 has already been plotted. So our next goal is to draw another line, and the reason that line is there is because we are trying to form a right angle, something that you could place a square into if you should try to do so. Now, once we have those two lines drawn out, you can see in the third equation written down, we have m equals 15 over 10. Now, where did 15 over 10 come from? Well, they came from these 2 points. These 2 points right here. If you start at the bottom point and go up to the line of the second point, the second square, the orange squares, you'll see that it goes up 15 spots. And if you go right to the second orange square, you see 10. So 15 over 10, which equals 3 over 2. Now, the actual answer is 3/4. So we didn't get the exact answer we were looking for, but we got close, which is represented on the graph by these lines. This one in particular. The small, you can't really see it, but the bright orange line extending just outside of the black line, that is the one we were looking for. That is the answer. And you can see we got pretty close. We almost nailed the line as far as the answer was concerned. And of course, the second graph will follow the similar process. You will also have to do some algebraic. You also have to do some algebra with this one. As you can see, 2y plus 9x minus 5 equals 0. To figure this out, all you simply need to do is you need to add 5 on both sides of the equation, then to subtract 9, and finally to divide everything by 2. Beyond that, everything will follow its similar formula. Now, number 6 is to show and explain the equation of a line that is tangent to the radius of 9 at point 0, negative 9. Now, we're going to be using, see our radius is 9, at point 0, negative 9. Now, you might be questioning, well, what's a radius? I'm about to explain that to you. So we have our square here. We're going to use that as our custom-made graph. You see here. And then we're going to do a circle. Now, the reason we're doing a circle is because the radius is half of a circle's diameter. And the diameter is a circle is 1 point from a circle directly across. It's the entire way across a circle. So in this case, this line at the very bottom, that is a tool that we're going to use to help us compare the differences between this graph and the second graph we will be creating. Now, we have the point 0, negative 9 here at the very bottom. We have 9, 0 at the right. We have negative 9, 0 at the left. And we have 0, 9 at the top. Like I said, this is to represent a normal graph. So here we have our point. This is our origin point. 0, 0 on a graph, if you will, where everything starts off from. And we have to go to point 0, negative 9. So what we're going to do is we're going to go downwards. So that right there will be our equation equation of the line. And if you look at this extended graph, you'll see the points that are plotted around the graph. You can see that the circle now has blue dots at every marker, and then the line at the very bottom, the line we've been trying to explain, is tangent to any of the other lines around it. Exact opposites. So this one, we see the points plotted at the very bottom, one point meeting the circle in one spot. And the second circle is going to be at point 0, +9. So it will follow the similar formula as its predecessor, except this time the line is going to be at the very top because it's 0, 9. It's the opposite of the original tangent line. Once again, we're going to put a square at our origin. We're going to go upwards this time to our positive point, and then we're going to use this graph to represent the two. To represent the point tangent line. And this time around, we are simply going to understand the formula y equals 0x minus 9, which means y equals 9. That's how we came about solving these two graphs. No matter what your x number is going to be, the product is going to be either a 9 or a 0. And as you can see, between these two graphs, the tangent lines are opposite of each other because their points are opposite of each other. If you were to do -9, 0 and 9, 0, you would get the same result. Tangent lines completely opposite of each other. And that concludes our Module 1, Chapter 8 lesson. I hope I explained this well enough to you guys. I know it was a bit of a struggle for me, but I managed to persevere and push through, and I hope that I helped you guys do the same. I will see you all in the next video lesson, and as always, stay brilliant, you rock.